I'm pleased to welcome you here at my presentation about the development of fuel cell systems at the FES in Zwickau. FES stands for Fahrzeug-Entwicklung Sachsen GmbH, or in English Vehicle Development Saxony GmbH. My name is Schaedler and I'm the Technical Project Manager for fuel cell system development and integration in Zwickau. So at first I want to introduce the FES at first. So we are one of the biggest German automotive car development partners and working for the OEMs and many of their suppliers with more than 850 employees. Our focus is the overall car development. So we have our own chassis and car body development, followed by the electronic system. You see the cycle. And our e-mobility development, as well as network management possibilities, where we can help our partners. The FES is also able to design and manufacture the prototypes that we develop, and can also produce small series of cars with approximately 800 cars a year, only for prototyping or small series. Our customers also assign us to design and plan the process of testing the prototypes under various conditions. So we have many climate chambers, approximately 80, and we also can put the whole car into the climate chamber and make automotive standard tests for certification and something like that. It's also superimposed partly with dynamic loads, so we also make these tests. Finally, the development process is rounded by our own driving test department and the technical documentation, where we can test approximately 100 cars simultaneously. So now I want to introduce you to the hydrogen and fuel cell technologies in order to make a contribution to the market or to the fuel cell market in Europe in the range of system integration and development. Yeah. So here you can see an exemplary system structure. In yellow we can see the hydrogen path with the recirculation. We are focusing on the hydrogen flow jet pump development. So we want to know how it works in detail, and that's why we are focused in this part, for example. The second part where we focused is the compressor and the drive development, where I also want to show some slides. And to know how the system works at all, we have our own system simulation or simulations of systems set up that I also want to show you. At first, I want to give you an overview of our fuel cell test bench that we developed in the year 2017. We have the focus on using of automotive standard parts to reduce the cost of the whole system. So where it's possible, we use them. We have built up our own implementation of the whole system structure and implement our own software to be more flexible when we change some components or characterization of these components. You can see here some exemplary diagrams of our test bench, where we change between 10 kilowatts and idle conditions. So Yeah, that's what I say. So all the components are equipped with the necessary sensors for characterization. So if you have any part for fuel cell system, we can test with our own software implementation. And here you can see also some summary of our main parts, actors in our fuel cell system. So we are able to arrange approximately 30 kilowatts with this build-up. Oh, yeah. So now I want to show you which experiences we built up in the last 2 years for the development of jet pumps, what is also a very interesting part in the hydrogen recirculation path. For the FES it was important to know in detail how the jet pump works and what geometric detail influence mainly the efficiency and the operation of the component. Because we want to avoid the necessity of an active recirculation pump to reduce the cost. That's our focus. So all tools for dimensioning, calculation and evaluation were developed in-house. In the picture you can see one example for a simulation result, and here at the bottom you can also see some verification simulation result in comparison to the analytical solution. So you can see we are almost at the same level for the efficiency of our simulation. The same plans we do with compressors, centrifugal compressor design. So we have our own software to create the geometries for the necessary requirements. So you give him mass flow pressures and a wish of RPMs or rotational speeds, and you can create your geometry in almost half an hour or something like that. So it's very fast to get some first results for verifying the geometry. The next step will be the rotational machine. We have our own software to do the analytical pre-dimensioning of the geometry. So here you can see, for example, 3 different configurations for the same requirement. And we also have catched the efficiency map creating with our software tools. It's only an analytical solution, but the next step will be an FEM simulation of the whole rotor with stator design. The last what we do was the thermodynamic behavior of the machine. So we tested some different cooling circuits and what power we can arrange with this art of geometry, and also the duty cycle. So what is the maximum temperature for different operation points we can simulate with our tools. Also the market is very interesting because you have very high frequent loads on the stator, so at first we do some market research for it. Finally, I think the most expensive part in the centrifugal compressor is the bearing. Because there is no software available at the market, for example, for the aerostatic bearing. That's why we develop our own numerical method for design of the bearings in dependency to the requirements. So we are able to catch all the forces in the room where the shaft can be positioned, in dependency to the rotational speed and the air gap that the geometry have. And we also do all the parametric studies at first to know which is the best configuration for our part. And at last, we do some CAD geometry for a 10 kilowatt electrical machine and the required geometry of the centrifugal compressor. Okay, here you see some some results of our own system simulation. So we built all the maps for the drive and the battery and the fuel cell stack, for example, where we get our efficiencies and all the efficiencies of our peripheral components get into our system simulation where we simulate all the necessary power that we need to drive the car, for example, here. So also the cycles were simulated. So we have the pressure losses in the system, for example, the filter and all the necessary peripheral parts. And we have the compressor as a main peripheral part because there is approximately 10% of the needed power for the fuel cell system to drive. And also here you can see at the bottom all the operation points for the VLTP cycle. Where are the points in the electrical machine map? And we also want to compare atmospheric and pressurized conditions. So that's one point where I am very interested in to get some needs for the pressure of the system. That's what I do in the last half year, where I make some parametric studies with a scalable membrane electrode assembly. For example, when it has a power output or 2 amperes per square centimeter with 2.5 bar, for example, there we can get some requirements of the pressure, for example. And also we make some own developed hybrid strategies you can see here. Yeah, last but not least, I only want to give you an expression of our booth at E45 here in the hall, where we present our new mobile charging system in relation to the second life usage of automotive batteries that we developed together with Audi and Riello. And we are proud to present it here in cooperation with the Energy Saxony agency. So thank you for your attention and much success at the Hannover to build up your network. And I'm happy to get some questions about this topic. And if you feel free to get in contact. Yeah, thank you.
Thank you very much, Markus Schaedler. Are there any questions from the audience? No? Okay, so you said you work with a lot of automotive companies together. So I'm wondering, Germany is known as the country for automotive. At the same time, we see that Asia is kind of further.
Yeah, Asia is running up, I think so. But we are focusing actually on the European market and hope that the OEMs will get in touch and start these applications where we can help for the development and integration of systems.
Okay, thank you very much. So if you have any further questions, there's the big booth of Saxony over there. So head over, ask some questions, and discuss the very interesting topic. Thank you very much again, Markus Schaedler.
Thank you for your attention.